Share the screen and let me discuss. So first of all, I must thank to Dr. Dharmen and his team that they have given me opportunity to express my view regarding the topic, that is non-parametric statistical analysis or non-parametric tests. So first let me share the screen. So till now I have not shared. So let me first share the screen, then it will be visible. Is it visible now? See, is it so? Is it visible? Just confirm it. So it is visible and I am audible, है ना? Okay. So I suppose that you all have, I mean, discussed and learned about the parametric test. So this is the counterpart of that parametric test. So in parametric test, we have a very crucial or say basic assumption regarding the form of the population, that the population should be normally distributed. In contrary to that, in non-parametric tests, it is not required. So whenever the population is not normally distributed, generally we go for the corresponding not non-parametric test. So to every parametric test, there is a corresponding non-parametric test, and we will be discussing one by one, and we will be doing hands-on as well on SPSS. So what is non-parametric test? First, we should know. So first we should know what is parametric, and then we should know the non-parametric. So as we know that parametric statistical test is one that makes assumptions about the parameters of the population distribution from which one's data are drawn. That is, we suppose that the parent population is normally distributed. And the counterpart of that, what we should do, yeah, one should do when the population is not normally distributed. So there we use the non-parametric test, and we since we don't bother about the form of the distributions, we don't have assumptions regarding the form of the distribution. That is why sometimes it is also known as distribution free test. So a non-parametric test is one that makes no such assumptions regarding the form of the population or its parameter, that the population must be normally distributed. So in this strict sense, non-parametric is essentially a null category, since virtually all statistical tests assume one thing or another about the properties of the source population. The maximum time we suppose we let the assumption that the parent population is normally distributed, and here we don't bother about the form of the distribution, that it should be normally distributed. So naturally one question comes into the mind, that which one is more powerful. So obviously parametric tests are most powerful when the sufficient data is available there. So non-parametric statistical procedures are less powerful because they use less information in their calculation. And let me put one thing, that most of the time in non-parametric tests, we take the data in different categories. So since we are not, I mean, using the actual data, we are using their ranks only. So that is why we are not using the actual information. That is why it is not so much powerful as the parametric tests are. So for example, a parametric correlation uses information about the mean and deviation from the mean, while a non-parametric correlation will use only the ordinal positions of the pair of scores. We don't use here the, that is why in parametric test we go for the Pearson correlation. There we use the actual values of the variables under consideration, while in the non-parametric correlation, and that is Spearman rank correlation, there we use the ranks of both the variables under consideration. So this is the difference between the two. That is why the parametric, if data is sufficient in number, then parametric tests are more powerful in comparison to non-parametric tests. Sorry. So these are some assumptions regarding the parametric test, and very weaker and fewer assumptions are for the non-parametric test in comparison to parametric test. So the above are the assumptions for the parametric test. The observation must be independent. That is, sample should be random, and the observations must be drawn from normally distributed populations. That is, parent population should be normally distributed, and these populations must have the same variance. This is one of the assumptions. While applying the t, you would have seen that the Levens test is there to test whether the equality of variance in the two groups is there or not. Or for the ANOVA, we use the Mosley's sphericity test to check whether the variance for all the groups are same or not. So that this assumption is also, one of the major assumptions for the parametric tests. Equality of means, variances, not means. The means of these normal or homoscedastic population. Homoscedastic means the equal variance, having equal variance. Must be linear combination of effects due to column or rows. So all the effects should be linear in nature. And these are some fewer and weaker assumptions regarding the non-parametric test. That is, certain assumptions are associated with most non-parametric statistical tests, such as observations should be independent. This is very important. For the statistical test to apply, the observation should be independent. It means the sample should be random. And here one assumption which is very weaker, that lower order moments should exist in mean variance like that. But these are fewer and weaker than those of the parametric tests. Now, what are the advantages of non-parametric test over parametric? So the assumption, very important advantage is that whenever the population is, small, then even if the population, but it don't happen that, but even if the population is normally distributed and we are having observations 6 or lesser, then we go for the non-parametric test. So probability statements obtained from most non-parametric statistics are exact probabilities, while they are the approximated one in parametric tests. So regardless of the shape of the population distribution from which the random sample was drawn, because we don't bother about the form of the distribution in non-parametric tests. So most of the time the probabilities are exact. But here these are in parametric tests, these are the approximated probabilities only. So if sample size are as small as say 6 or lesser say, then there is no alternative of using a non-parametric test. So there, if the observations are 6 or lesser, then we go for the non-parametric tests. So these are easier to learn and apply than parametric tests, that we know, because we most of the time we use the ranks only, and based on a model that specifies very general conditions. So no specific form of the distribution from which the sample was drawn. We don't bother about the form of the distribution. See, here we see that the distribution is non-normal. So we don't bother about its form, whether it is following Poisson distribution, gamma, beta, exponential. We don't bother about that. If it is non-normal, then it is sufficient to apply the non-parametric tests. So no specific form of the distribution from which the sample was drawn is important. So hence non-parametric tests are also known as distribution free tests, because we don't bother about the form of the distribution. Only we check whether it is normally distributed or not. Definitely there are many disadvantages of non-parametric tests, that losing precision, wasteful of data, because only we apply the ranks. So there may be a huge difference between, say, one person has obtained 60 marks and last person has obtained say 90 marks. but the rank will be just equally distant. So it has low power, false sense of security, that whether it is having a huge difference in numbers, but there's the similar difference in ranks. So that is false sense of security, and lack of software there. So let me, okay. So testing distributions only, higher order interactions not dealt with, and parametric models are more efficient if data permits. It is difficult to compute by hand for large samples, because it is very, I mean, difficult. It has very, complicated formula is there, so it is very hard to compute in numbers. But nowadays there are softwares and that calculate the distributions values of the tests, non-parametric tests under consideration. But nowadays tables are also available, and in case where a parametric test would be appropriate, non-parametric tests have less power, definitely. If sample permits, data permits, then parametric tests are always better than the non-parametric tests. So in other words, we can say a larger sample size can be required to draw conclusion with the same degree of confidence, because there we require more and more data, or larger and larger sample size, to get the clear decision, clear interpretation of the test under consideration. Now, these are some few points to be considered, to be kept in mind while performing these tests. The inferences drawn from tests based on the parametric tests such as T, F, chi-square may be seriously affected when the parent population distribution is not normal. But this is not so with the non-parametric tests. The adverse effect could be more when sample size is small in case of parametric test. So thus, when there is doubt about the distribution of the parent population, a non-parametric method should be used. In many situations, particularly in social and behavioral sciences, observations are difficult or impossible to take on numerical scales. So a suitable non-parametric test is an alternative under such situation. So use there the Likert scale and just get the ranks and apply the appropriate non-parametric test. So this is the tree chart for the non-parametric test. Here you can see these are the tests for single sample, and these are the for the groups of sample, and for the independent sample test these are the for two sample independent test, and these are more than two. And if we talk about dependent samples, for two dependent samples like pair t test, and like repeated measure ANOVA, so that alternative to that is the Friedman test. And here, if we talk about the alternative of the pair t-test, and that is this one is Wilcoxon signed rank test, and all are the alternative of that. And if we talk about the independent samples, then for the two independent samples, that is alternative to the independent sample t-test, that is Mann-Whitney u-test, and these are also as an alternative of that. And this is the alternative of the ANOVA. So here we use Kuskal-Wallis test. And if we talk about the single parameter, single sample test, then it is chi-square test and Spearman rank correlation. If we talk about the relationship, not for the single sample uh, mm, between variables, we talk about that. So binomial test may be used, run test for the independence of the sample, and one sample Kolmogorov-Svann test, we can see which distribution is the best fitted for the particular data. Now, one sample test, so that is binomial test. So H naught, that is proportion of two groups, is same. Here for in binomial distribution, it means we are dealing with the dichotomous population that is having output only two types of output, yes, no, present, absent, male, female, like that. So here we check that whether the two groups are having 50-50% things or not. So the probability is 0.5 or not. And to test the run test, we check whether the observations are random or not. So here, and for the one sample Kolmogorov-Smirnov test, we check that whether the sample is coming from a particular distribution. Now, if we talk about the two independent sample tests, so in parametric test, we have studied the independent sample t test, but in non-parametric test, for the two independent samples, we use this Mann-Whitney U test or Wilcoxon rank sum test, and we consider the null hypothesis that the median of the two groups are equal. See, in case of skewed data or say non-normal data, median plays as good as role as mean plays in case of the parametric test where the data is homogeneous. But if we are dealing with the heterogeneous data, definitely it is not going to be normal. So we are going to use the equivalent non-parametric test. So the equivalent non-parametric test to the independent sample t-test is the Mann-Whitney U-test. So there in independent sample t-test we test the null hypothesis that the mean of the two groups are equal, arithmetic mean. And here we check the null hypothesis that the median of the two groups are same. And the two sample Kolmogorov-Smirnov says similarly the assumption null hypothesis is same that the median of the two groups are same. Here only we consider that the extreme observations of the two groups are likely to be equal. So here is the data that we have gender in two groups, male and female, and we have a score for these on some test that this is it has a score 3, 7 like that. So we can perform the binomial test whether male and female are 50-50% or not, and randomness we can check through run test, and through Kolmogorov-Smirnov one sample test we can check whether this is coming from a particular distribution, say uniform or say normal or say gamma. And if we talk about the two independent sample tests, then we can check the equality of median of the two group. It means the median of male is equal to median of female, like that. So how to perform this test in SPSS? So just click on analyze, and there you will see non-parametric tests, and go to legacy dialogues, and there you will see the one sample case test, you can see run test, you can see binomial test, you can see Kafka test, every test is there. And if we are say using this two independent sample t test, then go independent sample test, then go for the two independent sample test and just click on that. So this type of dialog box will be opened. Here this is the grouping variable, that is we have coded one for male, say two for female, like that. And cholesterol is the variable under consideration, so put it in test variable and put grouping variable here, and you have to define the group which you have defined in terms of code, and go to Mann-Whitney U test. So just click on that. So you have to put here the continuous variable here, numerical variable, and just put the grouping variable here, and you have to define the group. So just click on that. So this type of dialog box will be open. So for group 1, you have, if you have coded 1, then you write 1, or if you have coded 2, then you can also write 2 for this group, and the another one for this group, and just click on continue, just like 1 and 2, and click on continue. And go to options button. So there you will see that descriptive statistic quartiles are there, so you can put tick there, and just go for the option. So this dialog box will be opened there, and just you will see the output that this descriptive statistics will be opened there. So there are two groups, 40% are there, 20% are there, say. So this is the group only, so this is coding, so there is no need to interpret this one. So we have to interpret this cholesterol concentration only for 40%. So the mean cholesterol is that 5.9, almost 6, and deviation is 0.5, and minimum and maximum is this, and these are the quartiles. So median is also almost 6, 5.9. So it looks that the data is symmetric or say homogeneous. Now here this is the main table that you can see here, that this is the this is the ranks for this Mann-Whitney U test. So the two groups are there. One is on the diet to control the cholesterol, and another one is on exercise. So 20 persons are there. You can see here the mean rank is 25 and another one is having 16. So you can observe a huge difference between the two. And similarly for the some of the ranks, you can see the difference. It is uh, 320 and this is 500. So you can see here and you can conclude or you can have idea that it is going to be rejected. The null hypothesis is going to be rejected. So this is the main table for the Mann-Whitney U test. You can see here the asymptotic significance for two-tailed. So you can see the p. This is p-value. The p-value is 0.014. So whenever the p-value is less than 0.05, so we reject the null hypothesis at 5% level of significance. And if we are taking 1% level of significance, then the p-value should be less than 0.01. So here we can say if we are taking 1% level of significance, this hypothesis is not rejected because the p-value is greater than 0.01. It is 0.014. But generally we take 5% level of significance, so it is rejected there. It means the median of the two groups, one on exercise and another one on diet, are not same. So the cholesterol level is reduced differently in the two groups. Now test for the two related sample, that equivalent non-parametric test to the um, pair t test. So here it is Wilcoxon signed rank test. So here is the data you can see here, and this is the age stage, and these are the week 1, week 2. So any you can also use it for the repeated measure ANOVA. So we can use here the Friedman ANOVA as well, but we can compare week 1 with week 2, week 0 with week 2, or any of the two we can compare. So Wilcoxon signed rank test, you can see here assumptions are same, very weaker, that the sample should be independent and variable should be continuous, like that. So how to perform this? Uh, this Wilcoxon signed rank test on SPSS. So go to analyze, and there you will see non-parametric similar by similar fashion, and go to legacy dialogues, and there you will see two related samples. Just click on that. So this type of dialog box will be open just like similar to that pair t-test. So you have to click on one and click on this arrow. So one will be here, one variable will be here, another variable will be here. And by default, tick is there on the Wilcoxon sign rank test. You can also go with the sign test or McNamara test as well. So you can see here that the two variables have been put here. See, at first and at second. So if you have any query, any question, please write down. At last, we will be entertaining. We will be discussing every question, every doubt. So please listen, and we will be discussing at last. So this way, and just you can go by the similar fashion. You can go for the options as well. So there you will see descriptive statistic quartiles like that. So this type of and then if you have checked for the descriptive statistics, so this table will be made there. So pre-score, pain score pre and pain score post surgery, say any surgery, and so this is the mean score 5.4 and 5.1, and these are the standard deviations and minimum maximum, and the first quartile is 4, second 50th percentile, this is percentile, so it is second quartile, and it is 5 and it is going to be 6.5. So it looks like very similar. So here these are the table for the ranks. You can see here these are the mean ranks are 8, and some of the ranks is having a huge difference, 32 and 88. So let us see what happens. So for p-value, we can see here that there is no difference between the two. It means the pain before surgery and after surgery remains same because p-value is greater than 0.05. It is 0.071. So here the null hypothesis is not rejected. And null hypothesis is that there is no effect of surgery on pain. I mean, pain is not reduced after surgery. Reporting is same on the basis of the p-value. We see the p-value, whether it is greater than 0.05 or less than that. Now come to K independent sample t-test, that is equivalent to one-way ANOVA. So as we check in ANOVA, what we check that equality of several means, more than two means. So here, since we are dealing with the non-normal data, so what we do, we do that we compare the median of various groups, more than two groups. So for that, we apply this Kruskal-Wallis test. You can also use median test as well as Jankhira-Terpstra test. So these are the three groups. Say they are taking the typing time for the typing. That this is the typing for a particular limit of the word, that particular words are being typed, and the person is taking 35 minutes and 28 minutes, 32 minutes, like that, when these are the beginners, and they are comparatively taking lesser time when they are at intermediate stage, and if are they are at the advanced stage, they are having these type of these times to complete or type that particular matter. So let us see whether all the here we consider the null hypothesis that the median score for three groups, beginner, intermediate, and advanced, are same. So let us see what happens with the uh, Kruskal-Wallis test. Assumptions are same, and to perform it on SPSS, go to analyze, then there you will see an non-parametric test, there legacy deluxe, and there you will say K independent samples. So just click on that. So this dialog box will be opened. So you have to put here the test variable, that is I mean pain score, and grouping variable you have to put here. And you have to define the range. If you are comparing three groups, then you have to define range from 1 to 3. If you are using say five groups, then you have to define group from 1 to 5. And just click on OK, because this Kruskal-Wallis test is already ticked by default in SPSS. Just click on that. So you will see here, and you have to define the range. So when you will define, so minimum is 1 and maximum is, say in case of this example, is 3. So just put 1 and 3. And now you, so 1 and 3 is here. See, you can see. Now go to options. So there you can tick on descriptive statistics and quartiles as well. This one. So now what is the output of this Kruskal-Wallis test in SPSS? You can see here. These are the ranks you can have. A, B, C, and drugs are there. And these are the ranks 35.3, 34.8, and 21.3. So this is going to be responsible for the rejection of the null hypothesis. So here you can see here p-value is 0.014, which is very much less than 0.05. Sorry, 0.05. So here we will reject the null hypothesis that the effect of the three drugs are not same in case of drugs. And if we are using that type test timing, so it is different, going to be different, because if the null hypothesis is rejected there. Reporting is same, that on the basis of p-value. Now if we go to Friedman test in SPSS, so this is the alternative to the repeated measure ANOVA. So here this is the extension of Wilcoxon signed rank test, as the repeated measure ANOVA was the extension of the pair t-test. So here we are not only taking the observation on the same group twice, we are taking the observation on the same group more than twice. Suppose we are say applying some exercise, we have put some persons on exercise or say on diet in reducing the weight, then we have taken the baseline data, then after 1 month, then after 2 months, then after 3 months. So this is the example of the repeated measure for the group, but this data should be non-normal in nature. If it is normal, then we will go for the repeated measure ANOVA, and if it is non-normal, then we go for the this Friedman ANOVA. So see here, this is the setup one that here say one person is say running on the treadmill, and with no music, with classical music and with dance music. So see whether the exercise is same or not. So we will calculate the median. We put the median of all three groups are equal. So let us see what happens with the data. So here to perform the repeated measure ANOVA, you just click on analyze and go to a non-parametric test, and then there go to legacy dialogues, and there this click on K related samples. So just this type of dialog box will be opened. You have to put the variable here, all the variables, and just go to statistics. So you can have descriptive statistics and all other things, and Friedman ANOVA is already ticked here by default. So we have put here all the variables, and then go to option. So you will see here the descriptive statistics as well as quartiles. So you can put tick here. If you are interested in quartiles only, then put tick here. So then finally just click on OK. So the analysis will be there. So this is the descriptive statistics for all the groups that the group is same. We have taken for thrice observations, with no music, with classical music, and with dance music. So these are the first quartiles score, and this is the second quartile score, and this is the third quartile score. Now these are the mean ranks. You can have idea that this is there is a difference in all the mean scores of the three music types. So 2.38 each for the no music, and 2.17 each for the classical music, while it is 1.4 for the 46 for the dance music. Now this is the chi-square test and say assumption. So here asymptotic value, asymptotic significance value, that is p value. So p value is 0.022, which is less than 0.05. So it means there is effect of music on the workout on treadmill. Reporting will be same as we have done in all the cases, that on the basis of the p value only. And if this is rejected, then we can go for the postdoc test, and there one by one Wilcoxon signed rank test will be performed. Now if we go for the chi-square test for the association of attributes, then we go for the analyze. Then here you can go for the descriptive statistics, and there you will see cross tab. Just see that. And there if you go for the analyze and their non-parametric test, there also chi-square test is also given there. So two way we can use that one. So go to analyze, then descriptive statistics, and then go to cross tab, and you just click on that. So this type of dialog box will be open. So you have to put one group here and another group here, and go for the statistics, cell frequency, like that. So every option you can explore, and just click on OK. So here we have put both the variables into different row and column, and you can go for the statistics to say here chi-square, and you can go also for other tests as well. You can also calculate the correlation as well. Sorry. So here you can see if we are interested in phi and Kramer's V to check the for the nominal data, and if we go for the then Kendall tau can be calculated for the ordinal data, or you can calculate the correlation as well. So just put we wish that observations observed counts should be there for in self display. So observed frequency should be there. So you can also put tick on that. Now go to cell frequency. You can see that we are interested in counts of observed values, and also we are interested in putting rows, columns, and totals in percentages. So you can put tick here in percentages. and just click on continue, and just then go for the table format. So it should be in ascending. You can also check for the descending as well and click on continue. So this type of table will be given. So you can see here male. So here gender is I mean grouped in two groups, male and female, and the preferred learning medium is books offline and online. That is books means offline, and this is online. So you can see here there are 60 persons who are male and like books reading, and similarly, there are 24 persons which are male and prefer online. So like that, this is the distribution of that. Now, to see here, for chi-square test, you can see here that the significance for all the different type of chi-squares are there. So you can see here Pearson chi-square, continuing correlation is there, likelihood ratio test is there, Fisher's exact test is there. So if we are interested in chi-square, then you can see here the p-value is going to be very, very high. So there is no association of attributes. We have considered the two. It means the two groups are independent. The two attributes are independent to each other. Yeah. You can see here also whether education is related to gender or not. So male, female, we have taken two groups. And in education, we have three groups: high school, intermediate, and UG, four groups. So whether we wish to check whether education is gender specific or not. So like that, we can compare the two. So this was all about today's discussion about non-parametric test. Now we will do one by one hands-on, and then you see, and then at last we will be considering the questions. So let me, I mean, share the different tests. So first, let us see that we wish to check the Mann-Whitney U test. It means we are interested in comparing the two group medians. Okay, so data is here. Suppose we are interested in, say, we are interested in performing run test, performing chi-square test, like that. So if we are interested in binomial test, then for the two drugs, this is the alphanumeric value. So you can see here we have given there are two groups that uh, one has given tablet and another one has been given syrup, and we wish to see the effect of these two on the two groups. So if we are taking the independent two groups, then we can go for the two groups. And if we are taking these observations, then it is the repeated measure observation. So go to analyze, and we can go for the non-parametric test, and there we can go for the Legacy dialog. And if we wish to check the binomial distribution, then we can go for that. And just you put the value here, and just you have to cut point, say 0.5. If you are going for the cut point, or the test proportion is 5.5. So it is we can put the cut point, say 20, like that, because we have taken only single observation on the single variable. So we are just I mean breaking the two groups, one having values above 20 and another below 20, like that, and just click on OK. So this is the two groups less than or equal to 20. So 20 is considered in this group, and greater than 20. So this is I mean highly imbalanced sample. One is having 25 observation, another one is having 5 observation. But you can break it accordingly. So here we can see that the two groups are not having same I mean effect. So it is the p value is very, very much less than 0.05. So this way we can conclude that the effect is different for different. So now go to perform another test. You just click on analyze and go to non-parametric test. Go to legacy dialog, and here we can check the run test whether this is independent or not. So you just click on. You can go for the options as well if you wish descriptive quartiles like that, and otherwise you just click on OK. So here you can see that the run test. So here the p-value is 1. It means the data is independent. Null hypothesis is not rejected here. Now go to independent sample test, that is Mann-Whitney U test. So just click on analyze and go to non-parametric test. Then go to legacy dialogs, and there you will see this one. Suppose you wish to see this one as well, one sample test. So we are just clicking on this variable. You can also check this one for the two variables. It will do it for the two variables as well. You can go for the options as well. If you wish descriptive statistics, click on OK. Otherwise, which distribution you wish, normal distribution, uniform distribution, Poisson distribution, exponential distribution, every one you can have. So this way you can see here. And these are the descriptive statistics, and this is for the one sample Kolmogorov test. For this is for the normal distribution, this is for the uniform distribution. But you can see here p value is very much less than 0.05 for both Tuesday and Friday data. So both the data are not normally distributed. You can see here the p-value, that p-value is 0.05. It is rejected, that it is also not I mean uniformly distributed. But on Friday we can say that this is uniformly distributed, because here p-value is very high, very high than that of the 0.05. Similarly, if you go for the Poisson distribution, then we can see that this is not Poisson distribution, not Poisson distributed, because the point p-value is very much less than 0.05 for both the data on Tuesday and Friday. Now coming to the exponential distribution, we can see here the p-value is very much less than 0.05, so it is not also exponentially distributed. So here we can have idea that it is going to be uniformly distributed, but only for the Friday data. So like that, we can get the best fitted distribution. Now come to independent sample test. So go to analyze, then non-parametric test, and go to legacy dialogs, and there you will see independent sample test, two independent sample test. So what we have to do, so suppose we are testing for the Tuesday data, and you have to put this grouping variable here, and you have to define group. So we have put one for another one group and two for another group. Just click on continue and go. You can go for the options, put descriptive statistics, click on continue. And here see we are interested in performing Mann-Whitney U test. So we can tick on that. By default, it is tick there. And if you wish any more, then you can put tick there and click on OK. So you can see here, this is the descriptive statistics. These are the mean scores for Tuesday and Tuesday. And here these are the two groups having 15 persons, that one is on tablet and another one on syrup. So these are the mean ranks score. You can see here it is 17.5 while it is 13.5 almost. So there is a considerable difference. So here you can see here that the sum of rank is 263 for tablet group, and it is 202 for the syrup group. Now come to the test. So Mann-Whitney U test, you can see here the p-value is 0.2. It means there is similar effect of tablet as well as syrup on the particular disease, because p-value is very much high, very much more than that 0.05. So the null hypothesis is not rejected. That there is no effect. There is no effect of there is no difference between the effect of the two methods, that is tablet and syrup. Okay. Now come to that say This was independent sample t-test. So now come to dependent sample t-test, and that is Wilcoxon signed rank test. So go for that. So here we have sale data, and we are interested in we are looking for the advertisement, that whether the data advertisement is effective in I mean increasing the sale or not. So we have seen the score of say 10 outlets before the advertisement, and the score of those 10 outlets after the advertisement. So here we wish to check whether the advertisement is effective in increasing the income of the how say some stores or not, in-house stores. So let us go for that. Okay, before performing any non-parametric test, first we should check the normality of the data. So let us check that. So go to analyze, and there you will see descriptive statistics, and here you will see this explore option. See, this is very important, explore, and just put variable 1, and you can also put 2 here, and just only go for the plots. There is no need to go for the statistics, and untick this one and tick this normality plots with tests. Normality plots with tests, and just click on continue, and here click on OK. So here this is the descriptive statistics, but this is the normality test. So there are two tests to check the normality. One is Kolmogorov-Smirnov test, and another one is Shapiro-Wilk test. So here you can see that the p-value is very much less than 0.05. Here p-value is very much less than 0.05. So it means both the data are not normally distributed, as we can see from the box plot as well. These is going to be outliers for both. These are the extreme observations, that is star, and this is O is for the outlier and X star for the extreme observation. How it is checked? That if any point, this is the box plot and these are the whiskers. So here this point is this one is Q1 and this is Q2, that is median, and this one is Q3. If any point is lying either below this first quartile or above third quartile, if it is 1.5 times distant from these end points to that of the quartile deviation, it means 1.5 times of Q3 minus Q1, either from Q3 or from Q1, then it is considered to be outlier. And if it is 3 times distant from these points, 3 times of that quartile deviation, then it is considered to be extreme observation. So you can see here, this is the outlier only. But here, this one sixth observation is outlier, while fourth observation is extreme observation, and we can verify it from the data, fourth and sixth. So fourth one is this one, say 90,000, very, very huge. And sixth one is also because it is 85,000. So like that. So now let us perform the Wilcoxon signed rank test. So go to analyze, and there you go for the non-parametric test, and then go for the legacy dialogues, and then go for the two related samples. Just put one and put another one, and you can go for the options as well, descriptive statistics, click on continue, and see here by default Wilcoxon signed rank test is ticked there. So no need to put tick. But if you wish that you have to see the results from these tests as well, testing the same thing, median of the two pair of observations. Otherwise, click on OK. So you can see here, these are the descriptive statistics, and these are the ranks, and these are the sum of the ranks. It is 30.5 and 24.5. So let us see what the test is saying, that the p-value is 0.76, very, very high in comparison to 0.05. It means the advertisement is not effective at all in increasing the sale. Okay, so let us move for another data. So this was the independent sample test, then paired sample test. Now come to the independent sample, more than two groups. So we'll go for the Kruskal-Wallis test, that is equivalent to the na and to the ANOVA, one-way ANOVA. So here we are having three groups. You can see here we have coded one for one no coffee and one for two for 1 cup of coffee per day, and the two for 2 cup of coffee per day, and the three for 2 cup of coffee per day, and four for 4 cup of coffee per day. And these are the heart rate. So here we wish to check whether caffeine consumption is, I mean, responsible for increasing the heart rate or not. So we have taken four groups. One group is taking no coffee at all per day, and another group is having 1 cup of coffee per day, and a third group is having 2 cup of coffees per day, and the fourth group is having 4 cup of coffees per day. So let us see. So just go to analyze, then non-parametric tests, then go to legacy dialogues, and there you will see uh, K independent sample test. Just put heart rate here and the grouping variable here, and you have to define group. So we have, since we are dealing with the four groups, so minimum is 1 and maximum is 4, and just click on continue. If you wish the descriptive statistics, then click on here, continue. Otherwise, just click on OK. So here you can see that these are the descriptive statistics, and these are the ranks, that 10 persons are there, and these are their ranks: 16.5, 19.6, 16.3, and 19.6, 14.6, and 31.3. So you can have idea from this mean rank that this is going to be rejected. So here p value is very much less than 0.05. It means caffeine consumption is responsible in increasing the heart rate, because it is not same for median is not same for all the groups, all four groups. Now come to Friedman ANOVA, and there we will have that is the extension of the that is Wilcoxon signed rank test, just like the repeated measure ANOVA. And Wilcoxon signed rank test is nothing but it is non-parametric equivalent test to the PRT test. So here we have marketing campaign example. Okay, so here we wish to see whether the advertisement is going to be marketing is effective or not in increasing the sale. So we have I mean, data on the starting date, and then after 1 month, then after 2 months on the same 15 outlets. So just go to analyze, then compare non-parametric test, then legacy dialogues, and here we go for the K related samples. So you have to select all and put them here together. You can go for the statistics as well. Otherwise, leave it and just click on OK. So you can see here that these are the descriptive statistics before, after 1 month, and after 2 months. So these are the mean score 82, 81, 80. So it seems that they are very close to each other. And you can see here, these are the mean ranks: 2, 1.8, 2.1, so almost similar. So here we can have idea that it is not going to be rejected. So here you can see the p-value is 0.766, which is very high than that of the 0.05. So here we cannot reject the null hypothesis. So what we conclude that the advertisement is not effective at all in increasing the sale of the outlets. Now the last one, that is chi-square test. So let us perform this one test, chi-square, for in association of attributes. So here we have taken that example that we have gender, one group having gender and named as gender, so having male and female, and another one is education, having the high school, intermediate, UG and PG as the category. So you can see here, this is the one is for male and two is for female. So let us perform this. So go to analyze, then compare this cross tab. Just put one variable here, another variable here, and just you can either click on OK or you can go for these as well. What you wish, chi-square test, then if you wish the correlation as well, then continue, and cell observed frequency we wish, and we wish that these must be presented in terms of percentages, so it is also okay. And you can go for the format, ascending is okay, no change. So now you just click on OK. So you can see here these are presented in terms of percentage, and if we untick them, then these values will be given in terms of numbers as well. And now you can see here chi-square test. So you can see the chi-square is showing that the p-value is very much very high, 0.945, almost 1. So what we conclude here? We conclude that the gender is not dependent on education. So education and gender are uncorrelated to each other. They are not associated to each other. Here we can conclude, and it should be like that. So I think this was today's discussion. Now you all are free to ask the question. So one by one, and let me unmute you all. Then we can. Are you able to? I mean, speak. So how can I unmute you all? You just try to unmute yourself. Okay, now you can unmute, I think. Anyone just unmute and
Yes,
ask the
sir.
question. Yeah. So now if you have any query, any question, everyone is, I mean, invited here to ask the queries, but
Sir,
one by one, it will be, I mean, good if you ask one by one.
sir,
Yeah.
I have joined late, so please, it is requested to revise the non-parametric test in short.
Okay, so non-parametric tests are nothing but these are the statistical tests which are, I mean, equivalent to those that of the parametric test. So equivalent to, I mean, any parametric test, there is a non-parametric test. Suppose you are just, I mean, checking the only difference is that if the data is normally distributed, we go with the parametric test, and if it is non-normal, then we go with the non-parametric test. Suppose we are interested in testing the whether the two groups are having same mean or not. So here we will check the equality of median of the two groups. And there we use the independent t-test, and here we use the Mann-Whitney test. So if we are taking the twice observations, twice on the same group, there we use the pair t-test. Suppose we are interested in looking for whether I mean, insulin is capable in reducing the blood glucose or not. So we have taken the level of the blood group glucose uh, level of the glucose in blood of a particular group, and then we have given the insulin to that group, and then after that we have taken the observations on the blood glucose. So and we perform the that pair T test. So similar, if that data is non-normal, so here we can perform the Wilcoxon signed rank test. Now we come to the more than two groups, and if the data is independent, then we go for the, if the data is normal, we go for the one-way ANOVA, and if it is dependent, it means non-normal. If it is dependent, then that, so ANOVA is nothing but it is extension of independent sample t test. And if we are interested in extending the that pair t test, so we take that observations on the same group, not on twice, but more than twice. Suppose we are interested in checking whether the exercise is, responsible or capable in reducing the weight or not. So we are taking the baseline data of a particular group of weights, and then after 1 month, then after 2 months, then after 3 months, like that. So there we will apply the repeated measure ANOVA. So if it is normal there, and if the data is non-normal, then equivalent non-parametric test to the repeated measure ANOVA, and that is Friedman ANOVA. So that is applied. And if we are interested in independent sample, that is one-way ANOVA, then we go for the equivalent non-parametric test is the Kruskal-Wallis test. So we have performed all these things, and you do. And if you have further any query, then you can email me, or you can ask to the organizers. Then we will reply the query. But right now, if you have any confusion, then we can remove it.
Sir, it is the summarized way of the non-parametric test for the every parametric test.
For every parametric test, there is equivalent non-parametric test, but the difference is that if data is normally distributed, we go with the parametric test, and if it is non-normal data, then we go with the non-parametric test.
Sir, it is the summarized table, and if it is available.
Yeah, in PPT we will share. There is a tree graph is there.
Okay, sir. Thank you.
Good evening, sir.
Yeah, good evening.
Sir, can you show me the table which you showed for Wilcoxon rank test?
Wilcoxon signed rank test.
Yes.
Yeah. See, here we are interested in looking the score. We wish to check whether the advertisement for any store is effective in increasing the sale or not. So here we have taken the score sale of the certain outlets before advertisement and after advertisement. So here we are, this is just like the non-parametric test equivalent to the pair t test. We have taken observation twice on the same group. So why we are going for the Wilcoxon signed rank test? Because the data is non-normal. So first we have to check the normality. How to check normality? Go on analyze, then descriptive statistics. There you will see explore. Just put both data here and go to plots and check this one, and just put tick here normality plots with tests. So there are two tests there, Kolmogorov-Smirnov and Shapiro-Wilk, and the box plot is also plotted there. Just click on continue and OK. So here you can see this table, that for both the tests Kolmogorov-Smirnov it is very much less than 0.05, and for Shapiro-Wilk as well. So it means it is showing that both the data are non-normal. So if they are non-normal, then we will go with the equivalent non-parametric test, and that is Wilcoxon signed rank test. You can have also idea from the box plot, but we rely on the test only. Now just you go to analyze, then non-parametric, legacy deluxe, and there you will see two related sample because we are interested only in two. Otherwise, k related samples we will opt. So you just put one variable here, another variable here, and you can go for the options. Say descriptive statistics, continue. Wilcoxon signed rank test is already ticked here by default. Just click on OK. So here you can see value.
Sir, when we write the description in thesis, so it is written as sum of rank. So do we have to describe this also, that the sum of the rank for this category is higher than the other category, like that we have to
Yeah,
write?
you can write because a little bit we are having in I mean idea without going into the test that this may be the considerable difference. But here it is showing that 24 and 30 is not a considerable difference because p value is not reject very much less than 0.05.
Okay, so this description followed by p-value should be included in the description of this table.
Yeah, definitely.
Okay, sir. Thank you.
That I although it is different 24 and 30, but it is this difference is that 6. There is difference of 6 say. So it is not considerable that the data the hypothesis is rejected.
Okay, sir. Sir, and one more thing in the when we are seeing this test, so along with p-value, there is always chi-square written on the box. So chi-square
Yeah.
is a separate test, and when we are running
Yeah,
these,
chi-square actually chi-square is the basic test for these.
so sir, is it basically when it is chi-square test only, then why separate name is given? Because
No, there are certain I mean applications of chi-square for what you are using that one. If you are using the, I mean, checking the equality of variance, say significance of variance, then chi-square is applied. If you are, I mean, checking the association of attributes, then it is applied there. So there are different type of applications of chi-square test.
okay, so
That is why
these
it is
tests
being
use
written
certain
here.
application of chi-square. That is why they are mentioning chi-square. So
Yeah.
that is why we are seeing chi-square in every table. So
Hmm.
okay, sir. Thank you, sir.
Any
Sir,
more question?
sir,
Yeah.
one question from my side. Chi-square is
Ah,
considered the parametric test as well as non-parametric test. So in
both.
which condition of the parametric test chi-square will be used?
When data is large, continuity is there, no cell frequency is less than 5. No cell frequency is less than 5. It means continuity is there in the data. Otherwise, we will have to pool. So that is why we go for the non-parametric test when observations are lesser in number.
Okay.
Sir, one more question. Sir, in the example, the coffee example on heart rate which you showed to us, it was showing that it was statistically significant in the high coffee consumption with increased heart rate. So in
Yeah.
that example, like we learned in the parametric test, that we will explore further by doing post hoc tests. So will that be applicable in that case also?
Yeah, we can apply. So there,
So
in non-parametric, it is not given in the, I mean, this one. Otherwise, we can go for that. Option is given, then we can go for that. Otherwise, pair-wise, you will have to apply. So again, you can go for the course that man-Whitney you test pair-wise.
okay.
I have a question for you.
Yeah.
I'm a clinician. The common mistakes researchers usually make when using non-parametric tests, like reporting mean plus minus standard deviation with mean Whitney. What's your take on that? And using Wallace without post hoc correction?
See, whenever you are using the non-parametric test, so don't go for the mean. We should go for the median, and standard deviation should not be used. The mean deviation should be used for the measure of dispersion.
Yes, true. And while using the Kruskal-Wallis without post hoc correction.
Kruskal-Wallis test without
Post hoc correction.
if you are using the Kruskal-Wallis test, so Kruskal-Wallis is, I mean, then go for the Mann-Whitney test pairwise. You can see.
Yes, yes, that will be more appropriate. What actually I'm
Yeah.
saying while reviewing some journals, I do get these kind of like issues, so I'm not
So
able to deal
always
with
suggest
that.
there that also perform if it is rejected, then pairwise perform the Mann-Whitney test.
That's true. That's true. And when data are skewed and but the sample size is large, is Mann-Whitney still preferred?
Yeah, definitely go for the non-parametric test. So Mann-Whitney should be used there in place of independent sample t-test.
Okay, the last two question I have that how do we adjust for confounders in non-parametric analysis?
Confounding, so that confounding, how you will do that in case of, so in case of non-parametric test.
Yes, yes, sir. Yes, sir.
So confounding, so how to you will have to manage it to make the observations independent if you are using that one. Otherwise, I don't think there is given in such type of softwares to deal with that.
Yes, that's true. Probably this is one of the pitfalls of non-parametric analysis, I would say.
Mm,
Thank you. Thank you, sir.
okay.
Good evening, sir.
Yeah,
Sir,
good evening.
as we know that in normal distribution, the mean median mode will be on the same plane. So for normal distribution, we use mean and standard deviation. For non-normal, we use median and IQR. So can we use non-parametric test in normal distribution data? And
No,
if
ma'am.
yes,
No, no,
then what will the
no.
difference? Because
The
see,
answer
there
is
is
no.
okay, sir.
The
But
answer
what
is
is the
no because
difference?
in
Because
non-parametric we use the ranks only, not original values. So it is better to use the original values. If it is normal, don't go with the non-parametric test.
okay, sir. But my question is, it will be both median and mean are on the same plane. So what will be the difference in if we use normal, non-parametric or parametric in the
Not
result? What will be the
it is not only for the median only, ma'am. All the values are maybe highly skewed.
yes?
So
Okay,
that
sir. Got
is median is the only that is not affected by the extreme observations actually. So that is why there we are using the median. So if the data is normal, then no issue. You can propose median as the measure of central tendency. No issue. But if it is
okay.
not normal, then you can calculate the mean deviation and standard deviation will be high if data is skewed.
Yes. Okay. Got it. Thank you.
Yeah.
Sir, can you once again explain the difference you told between outlier and extreme observations?
Ah. See, there is a measure of dispersion that is quartile deviation Q3 minus Q1, which represent the 50% of the data.
Yes.
So if any point is lying outside to either Q1 or Q3 and it is distant from these endpoints, either Q3 or Q1, and it is distant 1.5 times Q3 minus Q1,
Okay.
then it is considered to be outlier. And if it is three times the distance, three times of the quartile deviation to the end points, that is Q3 or Q1, below Q1 or above Q3, then it is considered to be a extreme observation.
Okay, sir. Thank you, sir.
सर कोई बुक ऐसी है जो हम रेफर कर सकें क्योंकि ये सब तो फिर भूल जाएंगे अभी तो बता रहे हैं आप बाद में हम कैसे देखेंगे
मैम ये तो बहुत मुश्किल काम है। बहुत सारी किताबें हैं। चलिए स्टेटिस्टिक्स में पर्टिकुलरली कोई एक जगह से बहुत सब कुछ मिल जाए तो पैरामीट्रिक नॉन पैरामीट्रिक टेस्ट के लिए पर्टिकुलरली, जैसे पैरामीट्रिक नॉन पैरामीट्रिक टेस्ट हम लोग इन्फ्रेंस में पढ़ाते हैं, तो पर्टिकुलरली कोई बुक बताना, आप बहुत सारे वीडियोज और वो देख लीजिए।
ठीक है सर
वीडियोज और बहुत सारा आजकल ऑनलाइन सिस्टम में पड़ा हुआ है, बस केवल सही चीज को सिलेक्ट करना है।
तो वो
और
कैसे पता चलेगा कि सही है
Sir,
बट
वो
वी प्रेफर
वेरीफाई कर
फॉर।
लीजिए, दो चार लोगों से, एक्सपर्ट जो होते हैं जैसे हम लोगों से कभी पूछ सकते हैं आप।
अच्छा, आपका फिर कोई कांटेक्ट कैसे हमें पता चलेगा? अभी आप तो इनवाइटेड है यहाँ पर, तो बात हो रही है, अदरवाइज बाद में
वैसे
कैसे?
अब अंबेडकर यूनिवर्सिटी लखनऊ में एसोसिएट प्रोफेसर हैं डिपार्टमेंट ऑफ स्टैटिस्टिक्स में।
लखनऊ में आप? ठीक है सर।
बाबा साहब भीमराव अंबेडकर यूनिवर्सिटी, इट्स अ सेंट्रल यूनिवर्सिटी इन लखनऊ।
ओके।
So I am there in the Department of Statistics. So you can go for the, you can visit the website of the university and you can search me there. So you can get my CV as well with the contact number, email ID as well.
थैंक यू सर।
And are these recordings available offline later? How for how long we can just watch these
You
videos?
just ask to the organizers. They are having recording of this session, so they will be providing you all the recordings, as well as if you wish, then this data set as well as the PPT you can get.
Thank you.
नहीं, रिकॉर्डिंग तो है सर, लेकिन वो हम उसको कब तक देख पाएंगे, मतलब ऐसा।
Yes.
कब तक देख पाएंगे क्या मतलब मैम?
मेरा मतलब कि ये बाद में रिमूव हो जाएगा या रहेगा हम लोग के पास में, कि हम कभी भी उसको खोल के देख
नहीं,
सकते?
अगर आपको शेयर करेंगे तो आप सेव कर लीजिए और क्या।
ठीक है, थैंक यू सर।
Sir,
हाँ,
how to find the strength of the association, whether the association is strong, moderate, or weak?
so you go for the correlation and you see the value. If it is more than 0.7 or zero point 0.7, it is going, it is considered to be strong, and considerable from zero point 0.5 to zero point 0.7 it is moderate, and less than zero point 0.5 it is considered to be weak.
Okay, sir. Sir, the concept of a small sample and large sample remains controversial all the time. Some textbook says that if it is less than 30, then it is a small sample, large sample. Now you just now told that n less than 6, then you take the non-parametric test. So this,
Yeah, so that I am not showing that, saying that it is I mean small small sample, yeah, very, it is very small, not small.
sir,
Whenever the sample is less than or equal to 30, it is considered to be small.
small sample. Okay. So in case of less than 6, it is very small. So it is expected to be highly skewed data. So we are using
Yeah.
non-parametric test. Yeah.
Yeah, yeah,
Okay.
yeah, yeah. Excuse me. So, any more question? किसी को कोई डाउट हो? Anyone is having any doubt?
Sir, you have told the about the cut points.
Yeah.
What are
Cut
these?
point is, I mean, if you are having a single group, but if you are willing to, I mean, break it in two groups, so there the cut point is needed. Suppose we are interested in, I mean, checking a particular value, but a mean value of the adult group and the minor group. So we will consider 18 as cut point.
Okay, sir. Sir, is there any value of cut point?
No, you have to decide.
Okay, on the basis on the sample.
No, you have to decide
Okay.
on the basis of your study, your
O-
wish.
Okay, sir.
Any more question? Or we should wind up?
सर एक बार कांटेक्ट नंबर अपना फ्लैश कर देते तो ठीक रहता।
कम कम मैसेज करिएगा।
नहीं, मैसेज नहीं करेंगे सर, कोई क्वेरी पूछेंगे, ऐसे मैसेज नहीं। थीसिस के रिगार्डिंग यही स्टैटिस्टिक्स
बताते हैं, लेकिन
एनालिसिस।
शेयर कर रहे हैं, एवरीवन एवरीवन कैन हैव इट। और किसी को कोई क्वेरी हो कभी भी पूछ सकते हैं। नाइन
सो
फोर फाइव
नाइस।
फोर नाइन फोर सेवन ट्रिपल जीरो
सर सर प्लीज एक बार, 9454।
शेयर कर दिया उसमें, देखिए। 9454947000। इट इज
सो नाइस सर।
9454947000।
जी सर, थैंक यू सो मच।
So anytime you can, I mean, contact us if you have
ठीक है
any doubt in statistics. So I
सर
will be happy to answer.
सर, डाउट तो रहेंगे सर, एक बार पढ़ाने में तो इतना जल्दी याद नहीं रहता है, और जब
सर
हम
आप
अपना
कहाँ से हैं
एनालिसिस
मैम?
करेंगे तब ज्यादा प्रॉब्लम आएगी एक्चुअली।
हाँ बिल्कुल।
सर
आप
Thank you
कहाँ
so
से
much,
हैं?
sir. Thank you very much.
Sir,
Okay.
please tell the book for the statistics for which learning the basics, sir. We have to go for the books. Not only through the online videos, we cannot cross the.
मेरे
Actually,
पास
ma'am,
पढ़ाने
there
की
there
आती नहीं।
are I mean several books which are good for a particular part.
ओके
So if you all will wish, then just tell me the topics, then I can tell the names of the
Sir,
book.
Sir, for tests, sir, just
for the
parametric.
basic, from the basic, we can learn from which books?
So if you wish to learn the basic statistics, then Gun Gupta, Das Gupta is having 4 volume. One is Fundamentals of Statistics, it is having 2 volume, and Outline of Statistics, it is having 2 volumes.
सर, आपने क्या नाम था? पूर्ण गुप्ता?
Gun Gupta, AM Gun,
ए एम
VK
गोल।
Gupta or SC Gupta, and so Gun Gupta, Das Gupta, these are the titles. AM Gun, Goon, Gun,
जी,
and one is Gupta and another one is Das
दास
Gupta.
गुप्ता।
Sir, one man, repeat it. One.
Fundamentals of Statistics and Outlines of Statistics. These are the titles of the books, both having 2 volumes. And the writers are Goon Gupta, Das Gupta. These are the titles.
Okay, sir. Okay, sir.
So I think it was.
सर, एक क्वेश्चन है कि कल हमको जीवामें पढ़ाया गया था, आज एसपीएसएस पे थोड़ा प्रैक्टिस
कल
किया
किस
तो
पे कल किस पे बताया गया
जीवामें
था?
करके, जीवामें करके एक नया सॉफ्टवेयर।
जमोवी, जमोवी होगा।
सॉरी, जमोवी, हाँ जमोवी।
हाँ, दोनों में अंतर ये है मैम कि एसपीएसएस पेड है और जमोवी फ्री है।
ओके,
लेकिन
बस
दोनों एक मतलब सिमिलर वे में काम करता है।
नहीं, कुछ ऐसा बताया था कि अगर लार्ज स्केल का डाटा है तो जमोवी वहाँ काम नहीं
हाँ, बहुत
करेगा,
बड़ा
ऐसा?
डेटा है तो नहीं डील कर पाएगा वो।
बहुत बड़ा, बस किस रेंज
हैंग
के
हो जाता
बियॉन्ड?
है, हैंग हो जाता है, हम यूज करके देख
अच्छा,
चुके हैं, हैंग हो जाता है।
ओके, ठीक है सर।
सॉरी। तो किसी और की क्वेरी कोई हो, एनी क्वेरी, एनी क्वेश्चन, आई विल बी हैप्पी टू आंसर। एंड इट वाज नाइस इंटरेक्टिंग यू ऑल। फिर भी अगर किसी को कोई क्वेरी कोई हो तो फिर भी हम लोगों को ईमेल व्हाट्सएप कर सकते हैं। सो शुड वी वाइंड अप?
Sir, one question: how to practice the SPSS? For example,
दिस इज अ वेरी गुड क्वेश्चन।
बेसिक क्वेश्चन सर, सबकी प्रॉब्लम यही है।
मतलब
हाँ, सो
when you are doing it is very fast. We cannot take all the कि इधर जाना है उधर जाना है. That is very much. तो how
हाँ
to
सर, ये
practice
चीज, हाँ,
basics?
सो
कहाँ कहाँ
आई
क्लिक
थिंक
करना है।
आई थिंक दिस इज वन ऑफ माय ड्रॉबैक्स ना, सो आई शुड गो स्लो।
Yes, sir.
ओके। सो अरे
ये
कोई
स्टेप्स
बताया
अगर
ही
याद रहे
नहीं।
ना तो काम कर
यू वुड
सकते हैं ना
हैव
सर।
टोल्ड मी।
ये स्टेप्स को पढ़ना जरूरी है। आपके वीडियोस भी तो होंगे सर? डेटा खत्म शायद।
सर कौन
बंद कर दिया क्या? नहीं,
आई थिंक नेटवर्क इशू और
यस
सर
आई थिंक सो, नेटवर्क प्रॉब्लम।
still 1 minute is left.
So it was internet disruption.
यस 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 सर, ये स्टेप्स का थोड़ा सा हमको आइडिया हो जाए ना एक बार, तो फिर हम किताब को
इसका
पढ़ के
मैम
भी एनालिसिस कर सकते हैं।
है
वही जब भी आप एक जना ने पूछा था ना कि सवाल कहाँ से क्या क्या टिक करना है, स्टेप वाइज एनालिसिस करना, मतलब एसपीएसएस में,
हाँ,
ये चीज इम्पोर्टेंट थोड़ी
How
सी।
to practice?
प्रैक्टिस
प्रैक्टिस भी
करने पे
करो।
ये है ना मैम कि आप एक एक चीज एक्सप्लोर करेंगे फिर उसी को पढ़ सकते हैं, तो बहुत सारी चीजें क्लियर होती हैं। अगर अभी
तो
कहिए तो
कभी
हम कोई अभी फिलहाल एक दिखा दें बहुत आराम आराम से।
Yes, sir.
अब उन्हें जो डेटा का आपने अलग अलग तरीके से जो ग्राफ बताए थे कि ये दोनों सेम नहीं है, वो चीज एक बार बता दीजिए, नॉर्मलिटी देखना।
नॉर्मलिटी चेक करने का ना।
जी,
गुड। वो सबसे पहले देखना है।
यस
whenever
वही
you
तो
are
देखना है।
going to perform any statistical analysis, first you should check the normality. First you
जी
should check the normality.
सर आपने नॉर्मलिटी के दो टेस्ट बताए, सफिरोबिल्क टेस्ट और एक दूसरा, तो कौन सा कब लगाना है?
दोनों ही आते हैं उसमें, क्रुस्काल वेलिस टेस्ट एंड सैपिरोविल्क, बोथ, but rely on the Sapiro-Wilk test.
ओके, थैंक यू सर।
Sir, is there any consideration like कि if sample size is less than so and so, then use Shapiro-Wilk, otherwise use the
वही
Kolmogorov?
वो ज्यादा, that is more sensitive, that is why you go with the Sapiro-Wilk.
In all the sample sizes, it will be the best test.
For all sample size you can go, but if they are lesser then go with the Sapiro-Wilk.
Okay, sir.
So let us do that. So go to analyze. Is it clear?
यस सर।
Then go to descriptive statistics.
ओके
It is okay.
जी
Yes, sir.
Then go to explore. देखिए यहाँ पे explore का आ रहा है
जी,
ऑप्शन।
यस आ रहा है सर।
अब इस पे क्लिक कर देना है। You just click on
ठीक,
that. So this dialog box will be open.
ओके
तो यहाँ पर जो भी वेरिएबल का चेक करना है, you just put that variable in dependent list. So here you can check for the both, but just we are checking for the one only. Sorry. And then go for the plots only here
ठीक है,
and untick this one and just put tick on normality plots with test C. जब
ठीक है
आपका खुल जाएगा ना मैम तो एक एक चीज इत्मीनान से देख सकते हैं।
जी जी
तो यहां पर नॉर्मलिटी प्लॉट्स विद टेस्ट पे टिक करिए, जस्ट पुट
जी
टिक ऑन द नॉर्मलिटी प्लॉट्स विद टेस्ट्स एंड जस्ट क्लिक ऑन कंटिन्यू। इज इट ओके नाउ?
यस सर।
And then you can go for the, here you can have statistics only, plots only, or both. So here we have by default it
बोथ,
is both. Statistics it will give and as well as the graph will be displayed.
प्लॉट भी, यस
Yeah, that is box plot and QQ plot. So just click on OK. So should I click on OK?
जी।
आप भी करते जाइए साथ में अगर हो।
अभी खोल के देखा नहीं सर।
कोई बात नहीं। तो क्लिक ऑन ओके, तो देखिए ये आ जाएगा। तो यहाँ देखिए डिस्क्रिप्टिव स्टेटिस्टिक्स आ गया पूरा।
जी
मीन आ गया, 95% कॉन्फिडेंस इंटरवल आ गया, ट्रिम्ड मीन आ गया, मीडियन, वेरिएंस, एवरीथिंग। दीज आर द स्टैटिस्टिक्स। यहां पर देखिए, दिस इज वेरी इंपॉर्टेंट। So these are
नॉर्मलिटी।
the tests of normality. The first one is Kolmogorov-Smirnov test. This is the p-value for that, and the another one is Shapiroval test. The statistics for Shapiroval is this, degree of freedom is this, and this one is the p-value. So you can see here both the values are less than 0.05. It means the
यस,
data is non-normal.
डेटा इज नॉर्मल।
Non-normal, ma'am, because here null hypothesis is considered that the data is normal. And since the p-value is less than 0.05, so null hypothesis is rejected. And since
ओके,
null hypothesis is that the data is normal and it is rejected, so it is non-normal. If it is non-normal, then we have to go with the non-parametric tests.
ओके। तो 0.05 से बी वैल्यू 0.05 से लेस होना
कम,
चाहिए।
हाँ, कम होनी चाहिए उससे, 0.5% टेस्ट ऑफ
तो
सिग्निफिकेंस
पॉइंट
देने के
जीरो
लिए।
जीरो थ्री है और 0.01
तो
है।
0.05 से तो बहुत ज्यादा कम हो गई ना, 100 गुना, 10 गुना कम हो गई।
हाँ जी, तो कमी तो कह रहे हैं आप कि कम होना चाहिए।
हाँ, जो कम कम होती तो रिजेक्ट हो जाएगी हाइपोथेसिस, मतलब सिग्निफिकेंट हो गया डेटा,
यस,
तो इट इज नॉन नॉर्मल, और नॉन नॉर्मल हो गया तो गो विद द नॉन परमिटिव टेस्ट।
नॉन पैरामीट्रिक, ठीक।
हम्म।
थैंक यू सर।
तो और किसी की कोई क्वेरी है? ये तो धीमे धीमे किया थोड़ा सा, हमें भी लगता है कभी कभी कि आई एम फास्ट।
वो सर आपको आता है
नहीं,
ना, तो
बात
इससे आपको लगता है जल्दी
नहीं,
जल्दी।
हम
थोड़ा
लोग
सा मैम इसलिए भी
एक्चुअली,
हो जाता है, थोड़ा सा इसलिए भी हो जाता है कि हमें लगता है कि आप वो शुरुआत वाली चीजें पढ़ चुके होंगे, और पढ़ ही चुके हैं। आज तो तीसरा चौथा दिन है ना शायद।
नहीं सर, इतना भी नहीं। वो एक्चुअली जमोवी पे अलग चीज था, यहाँ कुछ अलग है।
अच्छा, तो कोई नहीं, इसी तरह आराम आराम करके एक एक, वन वन बाय वन वी कैन एक्सप्लोर, एंड यू कैन आल्सो एक्सप्लोर।
बट सर सपीरो बिल्क में सर ने कल बताया था कि पी वैल्यू लेस मोर देन 0.05 होगा तो नॉर्मल होगा, वो नॉर्मल।
हाँ, तो नॉर्मल
और
होगा, वो तो
उसके
होता ही
लिए
है,
भी
वो तो
बताया
सब
था।
में होगा। 0.05 से अगर ज्यादा होगा तो नॉर्मल हो जाएगा, उससे कम होना चाहिए तो नॉन नॉर्मल होगा। एक्चुअली 5% इज कंसिडर टू बी क्रिटिकल वैल्यू। So if it is less than
0.05
0.05, it means it is lying on the critical region. So the null hypothesis will be rejected.
नल हाइपोथेसिस
गुड इवनिंग सर।
सिग्निफिकेंट। हाँ,
और नल हाइपोथेसिस यहाँ होती है कि डेटा नॉर्मल है, तो वो हो गई रिजेक्ट, तो इसका मतलब नॉन नॉर्मल हो गया। जब नॉन नॉर्मल हो गया तो नॉन परमिटिव टेस्ट अप्लाई करना है।
ठीक।
गुड इवनिंग सर।
गुड इवनिंग।
Sir, my question is, I have taken the subscription of SPSS, but I am not able to find the sample files that you are using. So, please, you can share, if you can share the file.
हाँ, I will share the whole folder with the organizers, so they will be providing you all.
Okay, sir. Thank you so much.
तो शुड वी वाइंड अप, कि और किसी की क्वेरी है तो बताइए। बंद किया जाए? ओके, सो बाय बाय एंड टेक केयर।
थैंक यू सर।
यस सर भाई।